In the course of this microcycle, a growth hormone is formed that is indispensable to cellular division. This phenomenon has been observed repeatedly in vitro cultures. If, under the effects of stress, or for that matter, any biological perturbation, the blood's inhibitors are diminished to any considerable degree, the somatid's microcycle evolves into a cycle that is both different and polymorphic. We then see the appearance of the various stages of a macrocycle, 13 additional phases in all. First, we notice a bacterial form that is the normal evolution of the microcycle when the inhibitors have been diminished. This endogenous bacterial form has been observed by many researchers, Germany's von Bremer being one of the first. The double bacteria which evolves from the preceding bacterial form is often observed in blood smears. Its particularity is the ability to divide itself by scissiparity to form rods. The rod form looks like a bacterial form, except that it is longer and its cytoplasm seems empty. It should be noted that this bacterial form possesses two terminal spores. The granulated double-spore bacterial form has a cytoplasm filled with granulations that begin to move. The maturation of the granulated double-spore bacterial form results in a mycobacteria well known to microbiologists. The cytoplasm is also self-developing. The mycobacteria that we have just seen has developed further and formed bubble-like enclaves to which it owes its name, bubble mycobacteria. Here we see the bursting of the bubble mycobacteria and the release of the elements of its cytoplasm into the medium. The yeast-like formations that result from the bursting of the bubble mycobacteria have a diameter of 4 to 5 microns. Even at this stage, they give evidence of a centrosome. The yeast-like formations proliferate and become ascospore forms, precursors of mycelial elements. From an assay form, we can observe the formation of a thallus, in which the cytoplasm gradually takes shape to constitute the young mycelial form. It is through a conjuncture and with peristaltic movements that the young mycelial form develops a thallic cytoplasm and eventually becomes an adult mycelial form. When this mycelial element reaches full maturity, its cytoplasm is extremely active. and when it bursts, it releases an enormous quantity of new particles into the medium, each particle capable of duplicating the entire cycle. Emptied of its cytoplasm, the thallus has a fibrous appearance. Incidentally, it is this residue from the somatidian cycle that is often observed in blood smears and dismissed as an artifact of coloration. It must be underlined that these forms of mycelial characteristics do not answer to any of the criteria of fungal growth. In fact, they are not affected by massive doses of amphotericin B, fungicide, or any other antifungal substance. The preceding observations lead us to a series of postulations. 1. The somatid is endowed with polymorphism, a polymorphism controlled by blood inhibitors. 2. Growth hormones are generated during the somatidian cycle. 3. In both the animal and plant kingdoms, cellular division requires the presence of the somatid. 4. When blood inhibitors are lacking, growth hormones are allowed to increase until they threaten cellular metabolism. Five, all degenerative diseases are a consequence of this disorder.